Okay, now let's take a look at another example. This time we have the absolute value of 2x greater than 8. Since the absolute value of 2x is greater than 8, that means, okay, now the distance from this number 2x to 0 is bigger than 8. Therefore, the 2x it has to be greater than 8. Right? And the 2x has to be less than negative 8. Because over this two area, no matter where 2x is, when you consider the distance from that number to 0, you see this distance is always bigger than 8, right? Like here, no matter where the number is, and when you consider the distance from this number to 0, this distance is always bigger than 8, right? It's always bigger than 8. So 2x must be greater than 8, or 2x must be less than 8. So we have compound inequalities, right? Okay. And let's consider how to graph the solution of this compound inequality. So x greater than 4 and x is less than 4. So the solution is from negative infinity to negative 4, or from 4 to positive infinity. Okay, let me do another one. The absolute value of 2x plus 1 is greater than or equal to 3. So the first step is on this number 9, we graph where this number could be. Okay, where the number 2x plus 1 could be. So it could be there, and it could be there. So from these two regions, we can rewrite this absolute value inequality into a normal inequalities. So this inequality, this area, this graph shows that the 2x plus 1 is greater than or equal to 3. Or this area shows that the 2x plus 1 is less than or equal to negative 3. Then we solve for each inequality. So 2x greater than equal to 2 and x is greater than or equal to 2. X is greater than or equal to 1. Over here we have we subtract 1, so 2x is less than or equal to negative 4, or x is less than equal to negative 2. Okay. Now once we've solved each inequality, then we consider the solution to this compound inequality. Here is 1, and here is negative 2. Now x, since x is greater than or equal to 1, so go all this way to here. And x is less than or equal to negative 2, so go all this way to here. And we said when we are solving for a compound inequality with OR, with R. So the solution should be all the area we have graphed. So the solution is from negative infinity to negative 2 and from 1 to infinity. So this is from negative infinity to negative 2 and from 1 to infinity, and we use this notation. So when we are solving for absolute value inequality like this, the absolute value of ax plus b greater than k, and where k is a positive real number. When we solve this inequality, it is equivalent to solve the inequality ax plus b greater than k, or ax plus b is less than negative k.